There we go.
Oh, all right, everyone on Zoom. So, all right, so yeah, if I don't know who was on Zoom, but if Alec is on Zoom or sorry, on Mike, hello, and thanks for helping on this project. How did I get here? So in class, I was taking an AI class and I was getting a bit bored and starting to think through what I could, do. And Terminator, creating some Terminator, something like that, or like some chess or checkers. And I went to the safe route to like do the checkers because it was less intimidating and So when I was thinking about this, I met with Alec, my friend, and we're trying to think about like how to grip, like how can we grab pieces. So in the traditional way of like playing checkers, you have like these flat pieces and you can move one piece at each cell and stack them to declare king. But the problem was that we're not playing, you're not like playing with you're not having two human beings playing with each other. You're having a robot to play a human being, and the robot doesn't really have the arm, the right dexterity or fingers to grab pieces in the right way or even to stack. So one of the, I created all these monstrosity of sketches. Those they look like some medieval, I don't know, medical tools. And we started thinking through how we started with a magnetic, like a magnet, like electromagnet to pick up the piece. And one of the problem was that if the robot dropped the piece, it won't probably stay in the same place. It will glide off to a different, position. So what we did, we had some like UFO shaped pieces, and then we had like a bowl of a ball in each cell in the board, and these UFO pieces will settle in those bowls. So that solved the puzzle of like put pieces moving around. So when the robot comes to pick it up, it's always in the right place or the same place. And the gripper, we had these gripper ideas, and all these were too complicated, and so we had to like figure out the proper way to like grab a piece. And so the flip, everyone was trying to ask me why do I need the flip, because I thought that if people were playing this robot and like all of a sudden flip the piece, because how often will the person be a king, or how often will the robot be a king? Not as often, but the moment it happens and they see that robot flip, I don't know, that would be like a changing moment, like, oh no, you did something new. So I was like, I really need the flip. And we needed the design where I could I wanted the robot to like get the piece and flip it to declare a king. So as I was starting with Jim, I was like sitting over there, and actually I literally sat there like just staring at this robot for the whole day, trying to figure out how to grab the pieces. And Jim came in and was like, because he usually kind of come in and try to like throw some, I don't know, like trying to like distract me or something like that. But he threw out a comment like, how about a belt? Like a belt. I'm like, actually, that's a pretty good idea. I like the belt.
He was probably messing with you, right?
He was definitely, I think he had, I don't know, he was trying to do something there. I wasn't really sure. So the first idea for the belt was that I needed it to have like some sort of like, what are they called, spikes to like hold the piece. But actually that was causing problems. That it was going to be going to make it even harder to actually grab the piece, and also make it was going to make it complicated, because I wasn't 3D, so I'm really terrible at 3D modeling. So that's why I actually had Alec in the loop, because he's really good at 3D modeling. He's really fast in 3D modeling. So I was like, you know what, Alec, I need you to help me with this. And he was like, yeah, get rid of the spikes and we make it way easier. And that was, then we went with this design right here. And that, it was a one try. Like we did it one day and tried it and it was great. That we just kept going. So the pieces, this is how the pieces look, and the bowl shape in the board. So the dot represents the king, and the empty space is just a normal piece. And then the board, this is the process of creating the board. As you can see, I think, I don't know how people create like, chessboards or whatever. But it's really, it takes a lot of time to create a board, like it really does take a lot of time to create a board. I just spray painting, tape it, and I thought the tip would be really good. But unfortunately, that wasn't, like my alignment wasn't really good. So I had some like zigzagginess in the lines. I had to like sit down and tape every single zigzag in the cell to like make it more perfect. And probably if you stare like too much on that board, you probably see the tape all over the place. But I advise not to do that because it will ruin the aesthetic of the board. So behind the scenes, so this is the system structure of the behind the scenes and how everything is kind of communicating. And right here on the right, left, right. You can see the Raspberry Pi, and then I lived it over there. So Raspberry Pi and robot controller. So I have an Ethernet cable connecting those two to communicate with each other. And I have a WebSocket running that sort of like helps, that's like the communication manager or server. And on the Raspberry Pi, it's like running the solver that's actually solving, we'll talk about that later. That's actually solving the riddle or the board. And then it also runs the gripper controller. So many people ask me, why did I do this? So why didn't I use the robot controller to like, the robot controller Tormach to like connect the gripper on there? And I'm really terrible at electronics. I'll rather start code, but that board, it has like weird connections over there. I don't really know what those connections are, so I didn't really want to tamper with them. So I'm really good at Raspberry Pis, so I kind of went with that route, and it was way easier for me anyway. And on the robot controller, we have the model client server. So this is just the server that's basically running the whole process of like take an image, extract the board, and run a machine learning model to like extract every single cell and determine what's the state of the board. And then within that same controller, running a checkerboard dashboard. So I created dashboards to like make it easy for me to interact with these things. So like, click a button to tell it to open a gripper or test something, or just to see what the board, like, so for example, if it extracts the board, I want to see what it thinks the board looks like. So it shows me that onto the user interface. And I have the storage going on. So the whole thing is, so when I take an image, I extract the board and then feed it into the machine learning model. And then, but before I do that, I need to make sure that the camera is in the right state. So there are a few problems that I ran into when I was doing this. Image processing is really difficult. Like it's very inconsistent. I was so hyped to like actually throw this image processing thing onto this project, and I don't know. I spent like nights trying to figure out what's going on with this thing. And the main problem was that the lighting is really crucial. If the lighting is off, the moment you have a shadow or like some glare or anything, and unfortunately, I have a board that kind of reflects everything. Like it's just like I don't know, like a mirror that's just there to reflect every single bit of light. And in the camera, it's like, oh yeah, this is taking all this light. So what I did is I had Chris, the younger Chris, to help me create a program that helps like extract it, basically set the right exposure of the camera to basically make the image look nice for the model to see. And with that, I save all the parameters, the exposures, the gain, whatever it is. I save those parameters, and that's where the storage comes in. So I save all that, and also save the so during the board extraction, I ran into another problem with image processing where extracting the cell is really difficult. Basically the grid. So what I did is created some sort of like a mesh of grid. So as you can see here, so over here you will see that there's those red dots. Those red dots tell me, or rather tell the system that hey, here's the whole mesh or the grid, and I can reuse that over and over unless I change the board, the size of the board or the positioning of the camera. That's the only time I'll have to change, and that's actually great because that has helped me a lot at the festival or Atwood Festival. I set that thing up and it just like all I had to change is the lighting. Like that's all. Like all I had to mess around with the lighting. So as you can see here, it's like, here's the board, extract the board and show me what you extracted. And actually, this actually did a great book. This did a great job. You can see all the kings and all the normal pieces all in the right all in the right places. So with the image processing, this is where I ran into a problem, is that when I extracted the grid, some cells are missing. And that's probably because OpenCV, if the line is not crossing enough or like touching, it will like skip that. So if you extract a grid and for some weird reason there's some pixels missing between one edge and the other, the OpenCV, the library that I'm using to process these images, will like, yeah, let's skip that. That's not a cell. Like, let's just leave that alone. And that, to me, I need that cell because it has the information I need. So that grid helped me a lot to fix that. And you may notice that I also I mentioned machine learning. The machine learning goes through each cell. Like, so for example, I basically, for 2 days, I was a photographer taking this image, the board, taking images of the board and extracting every single cell and feeding them into this tool to like train it. And then once I trained it, and then I had to test it, and I really sympathize with whoever is training, like OpenAI kind of stuff, because it's a lot of pain. Like it's painful. But yeah, so in the back, I'm using this solver. So in class, we were talking about Minimax algorithms, and I was like, oh, okay, I could use that in Minimax. Like, I could use that for my project. So I kind of stole that and put it in my project, and it's basically an algorithm that looks into the future of the game. So for each available piece, so if you go back to the board, I could go through all the available pieces, and if you look over here, the only available pieces are the ones at the front. All the rest, all the runs at the back, you can't move those, so they're not considered in the future of the game. Well, they are considered in the future of the game, but in this current state, they won't be considered as open pieces. And what the algorithm does, goes through every single open piece, moves it, and tries to play the game. Like, pretend what's the best move the opponent is going to make, what's the best move the opponent is going to make against this move, and keep doing that over and over and over until you find the right. So basically, if I jump a piece, if the algorithm jumps a piece, I get either that's good. If I don't jump a piece, that's bad. So I give it a score. Each time you jump a piece, that's a score. Each time you move, that's also a score, which is just 1 point. But if you jump, that's good. If you don't jump, or rather, if the opponent takes a piece or jumps, yeah, that's bad. And in each route it takes, if that route, the opponent is jumping a piece, yeah, don't even think about it. Don't go that route. Just jump, go to the next. Go to try out a different piece until you find a piece that maximizes. So that's where maximizes your chances of winning, and then minimizes the chances of the opponent. So that's basically this is a really like a really simplified version of the whole algorithm, but that's basically it. Like, look into the future, and the best future, take that. Leave the rest. And the machine learning model, I use TensorFlow, the TensorFlow library, which is a tool from Google, and Teachable Machine. So Teachable Machine, it's also built onto TensorFlow, but also owned by Google. It's a really great tool, but great, but not like when you train your model, not expect it to be good. It's you're going to have to spend at least a week to like actually figure out how to train the model to get the right model out of it. So with Teachable Machine, all I have to do is take images, create a classification model. It looks at an image. Oh, I see a dot. That's probably a king. Oh, I don't see a dot. That's probably a normal piece. And then it keeps going on with that. And yeah, that's the end. Any questions? Yeah, I'm rushing through so we can actually go to the robot over there so it doesn't die. Yep.
You said when it always has to take a picture in the same position.
Yes. So yes.
So does the arm always rotate to
the same exact? Yes.
Same
Yep. It will always, unless if it doesn't, then the robot is bad. So, yeah, that's if it doesn't return to the same exact point in space, then yeah, there's something wrong with the joints in the robot. Yep. Yeah. More questions? I'll be demoing it over there. So let's actually, I don't know whether the people will be able to see it, but let's run it before it actually collapses on us. All right, so the UI is over here, and this UI is basically for me to like, run everything. And whoever wants to play, you can, come in and make a move if you want. No one,
No pressure.
So when you can move wherever. So once someone makes a move, and this is where in the future I want to improve, I want to make it better in the sense that I don't want to be, looking after, like looking, making sure it's doing the right thing. I just want to be able to like, okay, once the person, makes a change of the board, it takes an image and then it hopefully does the right thing. So right now it extracted everything and you can see that you moved this piece over here, right? But you go confused that it's right now it's getting confused that there's a piece over here, which is like probably looking at the shadow or something. I could go in there and try to fix the lighting to make sure the lighting is okay. But for now, since this is a demo, I can actually quickly fix things over here. And actually this was helpful during the AtwoodFest was that if it made a mistake, I can quickly go in here and like I say, oh no, that's not the right thing. So I can take it over.
So it's cheating.
Not really, because I'm just telling you that hey, there's no piece over there. So once that's done, I could just say, okay, start. So when it starts, it sends it to the model. Sorry, the model's already done its job. It sends it to the solver, and then the solver kind of goes through everything, and then hopefully tells the robot to do the rest.
Where's the camera?
The
Sadiq, is it always seeing the board first time? Like for example, if you were to go move all the pieces around randomly and say, it's your turn, robot, would it then just start playing?
Yeah.
Whatever version? So it's-
Yes, so yeah, actually, that's actually the good thing about this is that I have it to only, care about the current state of the game. It doesn't care about the history or it just only cares about the current state of the game. If I move all the pieces around and you can move a piece. Okay.
See it jump.
You want to see it down this? We can actually give it more pieces. Jump. Okay. Okay, that's okay. So right now, if I can move the whole board around and take an image and extract it. Actually that did a great job. It didn't mess up. That's great. It didn't mess up. So the extraction worked, so it didn't mess up. So that's good. But in the future, I'd like you to just, look at the board, do it yourself and, keep going, like without me being there. Or anyone can just come in and move a piece and it will like sort of do it. So now let's think about it and hopefully it will jump a piece. So, still thinking.
Does it know if you make a legal move?
Unfortunately not, but that's probably, I don't really need it, do whatever you want, but I would probably tell it to punch someone.
Does your robot hold grudges?
No, but I would, it'll be nice if it did, because then everyone would be, polite to it.
Okay, well,
Does it take the piece of the jump?
Yeah.
did not count all the points it would have gotten. But it should have jumped twice.
Well,
Don't go there. Well, valid question. Robot's a little sensitive.
so here's the problem. So I had like a month to get this thing working, and there's so many things I needed to do, and one of them was to make sure it can double jump for multiple jumps. But I didn't do that because I didn't really get time to do that, and I didn't really get the time to do that. And there's so many things. Also, one of the things that I wanted to do, I wanted to speak. Like that's actually one of the things I really wanted to do.
Oh, you want to talk shit now too?
Yeah, I needed to talk, and it was on my list, but I wasn't able to do that because time and all that kind of things. But in the future, that is definitely going to be on the list.
Wait,
Dog
are you,
double
for the
jumping.
voice, are you gonna go like Scarlett Johansson or?
I don't really know.
Stephen Hawking?
Probably me. I don't know. Well, Chris, I don't know. Someone.
Stephen Hawking or Scarlett Johansson, I think that's the.
Anyone else make a move? Anyone? No. No one is risking that.
It's been at least 3 days since somebody got their hands smashed.
Oh. No, actually, the good thing is here, these
What if you just
pieces,
take the
touchables. Oh, which one? Yeah, you can move it. Well, it does it. Yes, it is. So yeah, I made this thing detachable right here, and that was actually, it's really helpful because sometime when you play this game, some point in time, the robot will reach in some sort of like a position where it forces itself to move all the joints in a weird way and rotate all the way around, which means that this arm is going to run into the table. And that has helped me a lot because this thing snapping off has helped me a lot because when that happens, it just snaps off and then everything kind of comes back and on. Because then, it's something that happens. I'm trying to figure out why it happens or when it happens because it's really random. Like sometimes I play the whole game and nothing happens. And then sometimes I play the game and then all of a sudden it's like, okay, let me do something new. Let me, you flip around and hopefully freak you out or something. But I would like to figure out what's and actually okay, I sort of like know what's going on, but it's based on the because this in order to make this robot move, you have two things. There's a linear move and a joint move. And the joint move is basically move, it tells the robot to move however it wants, but make sure you get to the point. Like so, for example, move from this point to this point. Move, we don't care, just move whether it's a straight line, whatever, just move from this point to that. But then the linear move is more like make sure you move in a straight line. Do not do anything silly, just go as straight as possible. And that is great if you're not doing anything that's going to if you're not doing a move that collapses it, or rather tightens the joints in a way that so for example, let's say that I need to move my arm through my body to over here. I can't do that because I'm running into myself. So you want to avoid that with this robot. So with the joint move, I can do that. I can just do this.
Should not stab us.
I could just do this to move from this point to this point. But with a linear move, I can't because it's trying to go through me, but it can't. So, the joint move is where I'm having problems with, and I really need the joint move because the joint move kind of makes it a bit more flexible to, move the whole. Because I'm really limited here because if this thing goes way too far that way, linearly, it can't. If it moves too far ahead, linearly, it can't. So if I make a joint move. I have more like variable motion, so you can kind of like, it doesn't matter where it is, where the point is, it will still make a point, as long as the joints can, make it. But
there's some way to prevent it from like going into a certain spatial area.
yeah, so right now I have it, moving into this spatial area, right? Well,
I mean, but avoiding that as it's making its motion.
yeah, well, you could do that, but then also you're creating headaches for yourself, because then you're trying to like limit it a bit more because you're limiting. If you limit yourself, it really depends on what you're doing. So for my case, I really need it to move in a fluid motion. Depending on what you, let's say, I don't know, if you had like, I don't know. Let's see, I'm trying to think of something here that could answer your question, but I don't really have it.
Essentially, the more constraints you apply to the arm, the worse it is.
Yeah.
Well, but couldn't you program, say, always stay 4 inches from the board unless you're picking a piece of. So you can move wherever
It's
you
not
can.
as straight. So it's not as straightforward. It's not as straightforward because the end effector will do what you're saying, not the whole rest of the body. Because the rest of the body is just like, hey, I need to make sure the end effector gets where it needs to go. So if you're moving linearly, let's say I'm moving linear from this point to this point. Well, it will just, so like it won't like move this thing just straight down like that. Like it won't like moving this one joint just like swinging one way, or rather just this joint all the way down here. It won't do that linearly because it will try to reorient itself in the sense that it still makes this stable. Like it still wants it to be pointing that way and also in the same orientation and everything, and makes sure everything goes in line, but also moves these joints in the sense that it kind of makes that move. Actually, if we tell it to move linear from here to there, it won't do it because really.
Hit end your turn, and then if everybody watches on the arm moves, you'll get a much better idea what it's like. The thing can't, so Aaron just, oh, you're good, Aaron just.
It's not the.
Oh, no, hit end on your UI. Yeah, just end your turn, take it.
The range of motion for each circle is that's the.
They all have to swing in arcs, and in order for it to solve the arc moves, it's complicated. So the more constraints that you give it, the worse and worse it does. So that's partially what it's doing is it's solving the kinematics on the path product controller. And that's what they're doing is you're giving it the This is the move and then it's having to figure out what to do. So if you watch, see how collapsed everything has to get in order to reach where it wanted to go. So what Sadiq's getting at is he's limited and this game board's actually challenging the motion of the arm because of where the arm is. But ideally, the arm would have gone upside down, but reaching down and have a big gantry motion. Any more questions? Can't help but notice it did take a piece, but
You know,
Are you planning on giving it like personality? Kind of like there was that art piece where it was swiping oil. That
Well,
itself.
already,
And
this is
when it started out, it was really happy, and then now it's just like ready to kill itself.
So when you tell them that you're taking volunteers who are happy to contribute code for it.
yeah.
Talk to EJ, I'm sure ChatGPT can figure that out.
Well, I would like to have it with something like personality, because I'm trying to get into, you know, things like making it, not this one specifically, I have a smaller robot that I'd like to do, but it's more like giving it a personality, like, hey, you're called Mr. T or called Mr. Someone. And then, you know, hey, can you move this piece to that piece? And then, okay, I can do that. And then like move. I feel like that would be cool. I feel like that would really be interesting. I don't know. Maybe it's just me.
Dress it up like the Pixar.
Yeah.
Anybody else get any other questions?
See the code, what's the software you got running in the back, and how do you interface with it?
So this over here, okay, actually, I didn't really go through the whole like in the structure. So this is the Pathpilot robot. Sorry, the Pathpilot.
Factory Tormach software.
Yes.
So it's Linux CNC is what the backend is running.
So it's basically the interface for this controller and the drivers. So basically, if I do something over here, it tells the drivers what to tell the robot to do.
But in your application, it's not just like Node.js or something.
So with my application, I'm sort of like, so I have a server running in here. So you can program this time within this, right? Within this code base. So this, the main goal is to give you a chance to like use this window to like program this robot to do something. But I am doing something weird where I have to like, I have a server running in here within this Pathpilot that makes I'm calling it a mover. So it's basically its whole purpose is to make this robot move based on what the solver returns. So the solver returns three things. It returns a position where to pick up a piece and where to take the piece and where to jump the piece. So those are the three. That's all it returns. It returns those things, gives them to the mover, and the mover goes, oh, I can do that, and it does that. So the whole interface is communicating through WebSockets. I have a WebSocket running over here that sends the message through Ethernet to the Raspberry Pi over here. So it sends you. So basically, that's.
And then your mover server, is that like C++ or what is that?
Oh, that's fine. That's fine. That's fine. So yeah, you can program it through Python. Yeah, most of the whole thing is Python. A little bit, let's see, JavaScript as well for their UI. Yeah.
Sorry, the iPhone.
Yeah, it's.
It's bug, it's all of it out.
Do you have canned moves and it really only have to go to 64 places? Or are you doing? Are you going to move it? Did you just say? Train to go to each spot and then save all of it?
Or like,
How do you get to the?
how do I get to the point? So in the Tormach has the library called Tormach programming. It's a long name, but anyway, it's basically a library that lets you interface with the robot. You tell it, okay, go to XYZ, go to XYZ, go to XY. Like you just tell it, give it points, and the function or the library will figure out how to do that. So I leverage that by since I know where this board is, I know where I know where the origin is. I can easily, and I know where based on the image that I take, I can calculate each position of each piece. Based on that, I basically tell the robot to go to XY. Like, hey, move the piece from this cell that's at XYZ to this cell that's maybe whatever it is. And then it will like, figure out how to get there. So I didn't really, no, I don't think you can, if you sat down and trained every single, I don't know, that would be That would be a headache. Like, I don't think it'll be, I don't think that'll even be, that would be a really painful way to do it. Because if you have like, if you try to train it every single cell, like, it will be good in a sense that it will always be perfect because you have like it, you have like programmed or trained it to like go in this place and make sure it's always in the right center or whatever, and then grab it and then like go to the next one and then make it. That would be so to me. I'm sort of like leveraging margins. So I'm like, all right, go to XYZ, but with the margin. So I can actually in the code, I have some margins where in the sense that if the sweeper came in and wasn't lined up, I can easily go to the code and say, margin negative, whatever, and then it like move in a way that kind of fits the whole piece. So yeah, I don't have it programmed. I feel like I'll go crazy if I did that. That would be.
So let's keep moving and then Sadiq will be around after the meeting. You know, I speed up the robot and work if it still works. It works. Gonna be nice to me. Yeah, sure. It should be good. It should still be a play. Good.
Laser pointer. Hey, hello, my project is a DND tabletop mini tracker. So what does that mean? Sorry, we'll get to that in a second. I forgot what they were my slides were in. Hi, I'm new to Madison. I moved here in April. Prior to this, prior to my current job, I was Air Force. So something I always like to bring up is if you have like high schoolers, somebody who's like considered in the Air Force Academy, really any service academy, but obviously I can speak a little more to the Air Force Academy. Well, I'll chat with them because there is a process to like do that. So yeah, obviously I always wanted to talk about that. And then my prior job, my current one, I did all kinds of cyber operations. Non-recording, I can talk a little bit more about that, but I'll get more. And then my current job, I do bullet research, which top level, I write exploits for software or hardware, which is like. But yeah, all right, cool. Little sideline. So what am I trying to do? So if you play D&D, you may know that you're like, oh, like sitting around the table, collect storytelling. I might have like a little figurine that I have that's like my character, and then maybe we have like grid paper or something up that we're drawing onto, like this is the map we're all looking at, and I put my physical mini, and it's all fun and good. Physical stuff is cool. You also either just like purely online with like virtual tabletop systems, you can have really fancy looking battle maps, you can have like some animations. You can have like fog of war and Field of View things, but it's like, oh, like I'm in like a corridor of like this labyrinth. I don't know the whole layout, so as you like the characters like moving around, things become more known to you, and like you can see like the map kind of building as you're like moving through. And so I thought, wouldn't it be cool is if we put those two things together. So what if we were able to have a table with a TV literally on it? People do this. Like we're gonna go through a bunch of established stuff, which I think is kind of interesting how people solve this. But we have a TV that we put out. It has all this cool virtual battle map stuff. We put our minis on top of it. But wouldn't it be cool if the TV knew where your piece was? So when we're talking about like how that auto discovery of as I'm moving my way through like this labyrinth, that becomes more known, instead of having to like click and drag with like virtual icon, and I could just pick up the mini, put it in a new location, and the system would update the state. So yeah, there's a couple ways people solve this. I'm not the person. So the one that's probably like most established for this specific use case is called material plane. It seems pretty sweet. And it leverages an overhead infrared camera. People have done it with infrared touch frames. You can literally put like these frames around TV, and it makes it touch sensitive. And just basically by shadowing, beam an LED out the side, one side of the frame. You touch somewhere, it creates a shadow, and the other side can see that shadow. And then what I thought was like probably the most creative use of how you would locate an object on a screen is this under table projector system. So I thought I'd start with kind of walking through how people have solved it, and then we'll kind of go through my first iteration and then my current iteration. So the overhead infrared camera, basically we throw this camera up above on the ceiling or whatever. It's sensitive to the infrared spectrum. And then underneath each of our miniatures, we just put a little base that has infrared LEDs that chirp some specific code. So they just kind of flash some identifier the camera can see, hey, ID is so-and-so, it's at these coordinates, like through the camera. Tell the table, this is where you should move the virtual avatar to be. It's got some really cool advantages, like, if we have a bunch of minis all over the table, I don't know, however many you want, but to say that you had dozens of them, they can see all of them simultaneously because it's above the table looking down. And then, yeah, so you have all of those minis, they don't match one another. Code wise, it's fairly simple to implement, it's just like, where is this flashing thing? X, Y, tell the table be that. But obviously there's some disadvantages. You have to have this camera mounted to your ceiling or on a boom or whatever, which is kind of why I did not want to go down this way. It's like I didn't want to have to physically mount that camera. What happens if either your players bump the table or even just you have the thing like set up, but like you take the TV off the table and you put it back, now you do this whole recalibration every time you set it up. So that's why I didn't go this way, but there's a guy who makes these bases and like I said, overall, it's pretty sweet. The touch frame, is that basically a frame you can put on TV for like $200-ish for like a 42-inch TV, which is roughly the size that you like generally want for this type of thing. So very simple, it's inline, you can build it into a frame that the TV is also built into, so when they move together, so there's no calibration. But you do start having some issues and that, well, what if I pick up my mini and you pick up your mini, they leave the plane of where it's able to see where things were, and you flip them back down. It doesn't have a way to discriminate between each one. Or like if you picked up one and placed it, we could kind of infer that must have been this one. But yeah, pick up two, oh no. So that not being able to handle multiple minis was problematic for me. Third one, I thought this was clever, and I wish I could re-find like the paper or whatever I saw where they talked about this, because it was like some grad students and some college. But basically, what they did is they had a screen that you lay down, basically over a box. You have a projector on the bottom, so it's basically rear projecting through the screen. So instead of projecting onto the screen and out, it's projecting into the screen, and then you're seeing the top level side of the screen. And because it's partially see-through, you're seeing the projection through the screen, it literally just put QR codes on the bottom of each one of those figurines, put a camera underneath that. QR code, that's my identifier. Where is it on the screen? Boom. So in terms of like code implementation, relatively simple. You can track 1 million minis, however many, what's the density of this on the screen. I thought it was really clever, but it does have the issue of it's not even anything close to resembling portable, right? Because you've literally built this entire arrangement that lives somewhere now. You have to build it custom because actually like Johnny builds this. But I thought it was clever. I really liked it. So yeah, so my first approach was some sort of a triangulation. So before I run like the little video, quick talk through, what if on the mini base, we have infrared emitters on the sides, and then all along the perimeter of the table, we have infrared receivers that have a fixed field of view. And so if I flash some code on the mini base, then depending on which receiver was actually able to see it when I did that transmission, let me basically bound down the region on the table that it must have been because these receivers could see it, but these ones could not. Here we click. So this is kind of a poor animation for it because I definitely changed how I did some things, but the blue dots are kind of like the regions of where it could be on the table, with that red circle representing the actual mini base, and then the triangles are the little lines of the triangles are basically trying to solve its way down of where this thing must have been. Like so, I came with some other ways, but since we're not pursuing this way, we're not going to fix the animation. But yeah, so it kind of solved that. I don't have to have an overhead camera, right? It's something I can build to the frame. It only requires that initial calibration when I set it up, but it requires this entire like frame system to be built. It has to be sized to the TV Depending how accurate you actually want it to be, that's adding more and more receivers. They cost money, each one of them. So yeah, I decided that it ended up being a little bit problematic, so I ended up walking away from this approach. After I did a lot of circuit board design and actually started building out hardware, and I was like, this ain't the way to do it. So I had a realization, what if we did this like Duck Hunt? So I don't know if you're familiar with how Duck Hunt actually worked back in the day, but you had your little light gun, you had ducks on the TV, and you pointed, and somehow it knew where you were pointing to shoot the duck. And really simple trick. The light gun is nothing more than a long tube with a photo of a resistor at the back of it. And when you pull the trigger, it takes the screen, makes it go all the way black, and then it shows a white square where the duck was. So if that photoresistor changes and it says, oh, I saw that light, boom, you must have been aimed at the duck with some degree of accuracy, and it's a game at home, right? Like, it's accurate enough to be fun. So basically I was like, well, what can we confer information on the screen by flashing at it? So effectively, we have the screen divided into a bunch of cells. That's like the grid of the board, like all the valid places your mini could be, because those are like the grid tiles. And each one of those grids is literally just flashing binary. So it's flashing frame after frame, brightness changes. We pick that up with the light sensor. I now know where I am. And then through a side channel of some form, I communicate that back to the table. And my implementation will be via Bluetooth. So it's going to be Bluetooth at low energy. It's going to feed back. This is where I am on this table. So yeah, so we do get the advantage of pieces don't mask each other because they are picking up their location information from the table itself. So they're sitting on the table. We don't have them like somehow like shielding one another from the light sources. Again, we can track as many minutes as you want. It's also a practical limit. I don't know how many you actually want to track, like 4, 6. And then we do get some advantage of that. The required hardware to run this is only the mini bases. So these circuit boards that we build out that are an inch in diameter, attach them to the bottom of your miniature, put on the table. That's all you need to run it, minus the laptop you already had because you were doing a virtual tabletop, so you had something that was driving. A little bit more complicated, and then we are aiming for circuit boards that are an inch in diameter. I had been thinking I would have brought the version 1 that I built, because I do have boards that are 1 inch diameter. They're really tiny parts, and so I have another side project of building out a manual pick and place that has mechanical advantage, so that you can place these things without using a full pick and place machine. Because I don't have the studies in hands, and I don't know, some a better way to do it. So this demo in the bottom left corner, let's see if I can't laser point on these screens, but basically on the bottom left you see the red thing. It's just the light sensor taped to the screen, and it flashes a couple times at it. What I showed before with the really big white and black flashes, we actually don't need to go nearly to that degree. We changed the like 1% in the relative brightness of the screen and confirm the information. And in this demo, basically I click a cell just that way I know which cell I'm trying to see as the output. The screen sends every cell simultaneously, and then the right now it's just a little Raspberry Pi up to the side. That's when this light sensor is actually reading that and it comes back. And the cool demo part is that what I sent of that grid is what the Raspberry Pi says that it saw. And because we're sending binary information, we actually send checksums too. So it actually could validate a checksum and be like, did I receive, like, not only did I think I recorded it, does it validate to get a checksum that was also sent within the transmission. So a couple things moving forward, some things I'm trying to think about. This is obviously a really slow transfer scheme. So every time you moved the piece, how long would it take to transfer the information? This particular demo is about 4 times slower than it needs to be technically, because the sensor has 4 channels and you can't skip a channel. So it's reading red, green, blue, and general brightness. I'm only using the general brightness channel, but it has to go through the sequence with a 25 millisecond acquisition time per channel. So 1 bit per 100 milliseconds. Obviously a very slow way to do it. So we'll get a speed up just from moving to a single channel sensor. But if we add an accelerometer, and really we add an inertial measurement unit, so we have a couple things, so we don't need the compass, but the accelerometer and the gyro. Then after I've like initially figured out where that miniature is, you pick it up and move it. Well, I know that I was moved and I know I was moved with these acceleration and rotated this way. And so when I place it, I should have a pretty good estimate of where I am. Obviously, this is an I should because it's the future and I haven't solved this yet. But then you can just do basically like I guess a check where the main says, I think I am here. The table can just flash that single cell and be like, oh yeah, I saw that. I must be there. Now we didn't have to flash the entire table. We didn't have to send a bunch of information. So that would make it a lot more dynamic. You pick up a piece, move it, and it should, to you, at human reaction times, be sufficiently instantaneous. I am sensitive to the what, especially with that accelerometer scheme. What happens if you pick up the piece and then somebody bumps the screen? Oh shoot! Like I know where I've been moving, but now I don't know where I am relative to the table. So a couple things I was thinking on this. One, the one that I kind of like the best is if I took one of those mini bases and basically strapped it to the table itself. Now the TV has an IMU attached to it. So when you move it, then we know how TV moved, therefore we can solve where this piece is relative to the frame of the TV. That might also have a secondary benefit if I can make you talk to that mini via a serial connection. We might not actually have to install any special software in the computer to run this. Your computer's already running probably a Foundry virtual tabletop. You've installed my thing as a module, and there's an API that exists called Web Serial, where literally a web browser can talk to a serial device on your computer if you like allow the permission. So if you can talk serial to this little device that's attached to TV, it effectively acts as the broker to all the other pieces. You don't have a driver, extra software you have to install. This does not give you like a touchscreen. So if you like walk up to a door and like, I want to open this door, yeah, get your DM to like open the door for you. But since we have the accelerometers, potentially, we can do like gesture recognition, right? So you like tap your mini next, double tap your mini right next to a door, the door swings open. So potentially how we could solve this problem. And then like I said, we're not running a compass. So what if your game allows you to have like a flashlight? It'd be really cool. You can like turn your piece and move the flashlight to like this dark area. And so my initial thought on that is if I just had a second light sensor pointed at the screen, after I've solved where the first one is, it's like in the center of the piece. And the second one, well, now I can basically try to solve what that one is. And that would give me a rotation on the screen. That's kind of how I'm thinking through it. Otherwise, if you are so curious, the code is on GitHub. And they're both the same QR code. The first one's done with like a really you can make QR codes that look like actual images, which is kind of a neat trick. But if your phone doesn't actually scan the first one because it is kind of garbly, then there's backup one in case you actually figure it out. Some interesting tech notes is that it is actually all done in Rust, which gives me a lot of really nice compile time guarantees. So I can build certain things off state machines. That way I can't code certain things wrong. The example I like for a state machine coding for physical things is like you have a robot. Having picked up a piece is a state that I am in. So it no longer makes sense for me to pick up a piece. That should not be an API call that I should be able to do with a robot because that's not valid. And at runtime, I could do a check like, am I holding something? Yes, don't do this, throw an error message. But with Rust, it's really easy to build out that state machine in code. So at compile time, you could actually stop it and it would not compile, saying your code says, piece, I picked up a piece, I picked up a piece, it would actually not compile. So I think it's a neat trick. So there's a lot of really nice things for physical systems that programming language like Rust gives you. But yeah, questions?
So your example that you're using the same format as old school Nintendo talk about. Do you have like a light emitter that's this fixed position above your portal?
No, so we're literally using the screen to transmit the information.
And so the screen provides that feedback?
Yep, so you have whatever your screen would normally be, and then I just run it as basically an overlay, or in Foundry, I would take over the top level drawing channel, and then I make it a little bit darker, or I add a little bit of light to that grid, and use that light shift, and we're talking about the relative light shift. So what was it before? it just got a little bit brighter, oh, it just got a little bit darker. And I know I'm being transmitted information right now. All right, let me refer if that was a 0 or a.
So is that possible to, then it really doesn't matter what size your mini is, you could have like something as big
You
as.
have something big, you have something really tiny, because the light sensor is like tip of a pencil, it's like ridiculously tiny.
And so if you had a bunch of little eraser size minis on there, it would pick up 100.
Yeah, spots. I think you'll, so the biggest space constraint right now I have is what battery I bring with. So I'm using a coin cell battery, I'm just trying to use the Sierra 2032, that's like your standard quarter size looking battery that Diamond does, really pretty cheap. And so that it's 20 millimeter diameter, 20 to 2032. You can go smaller. I'm already estimating battery life, standby battery life in years, and then active, like I'm using this, I'm playing games and like potentially weeks, like it's absurd. It's most of the time you can actually be sleeping. You don't have to have the microcontroller on most of the time. And you can wake it up via the Bluetooth channel. Per 1-2 milliseconds, every second it wakes up on the Bluetooth channel. It's like, hey, do I need to do anything? Yeah, you can keep it off most of the time. Particular microcontroller I'm using is an RF52, which also has some really cool power management stuff. So normally when you go to a sleep mode on a microcontroller, it tears down the program state. You wake up from an external interrupt, you like pull out of like flash or something with state you were in. And the NR52 really dumb. You say I want to wait for interrupt so and so, and then it just turns off almost everything for you except for the live RAM you're using. And then when that interrupts, whether it's like a timer, external timer that's firing, or I say external, it's an internal timer for the chip, or the radio tells it to wake up, then it boots back up, your code keeps running from that point as if you've never stopped. But technically you were actually off. That's a really cool chip from a power perspective. So.
You talk a little more detail on the scan, you're scanning with variable size black or white blocks, basically.
Yeah.
And it's just like a straightforward search algorithm, you say it responded here, nothing responded here, therefore I don't need to search here anymore.
So I was initially like, can I do this in like a log 2 like approach of like, oh, like flash half the screen, did I see it? You know, the other side that saw it, flash half that. But it ends up working out that instead of doing the more complicated, it takes roughly the same amount of transmissions if I just send the X and the Y coordinate as bits. And so in the little demo I had, for the side of the grid that I actually had, it was like 6 or 7 bits for the X, like 5 bits for the Y, and then like 4 bits for checksum. So we're talking generally, even on a very large screen, if we're aiming for roughly inch resolution, it's 15 to 20 bits to tell you where you are, and that's to everybody simultaneously. So yeah, I was like initially like I could do this cool search, and I was like, I'm literally gonna send you the binary data of your X and your Y on the like I said, with a checksum, because obviously like what if we're talking about like there's animations, right? So what if you have like flickering candlelight behind when it's transmitting, and I misread one of those bits? Then I would be able to at least detect it with the checksum.
Any other question? Are you planning to commercialize this or just for fun?
I don't know. In general, the real answer is just for fun. I am building out certain design decisions in the hardware selection and processes such that maybe they could be commercialized. But the initial intent is for me.
Thank you. Great, I think that leaves me. What do they say about the best? Or the last.
Jim, that means you're up too, but I'll let you go next.
Jim spent a lot of time on a slide, so.
Alright, so July 12th and 14th, no doubt you all missed me. As I was in New York for this conference called HOPE. HOPE stands for very appropriately Hackers on Planet Earth. It's every 2 years. So the last one was in 2012 and 2022. I caught the last set of talks. What's kind of neat with this conference is they stream online live And so you can catch the streams while they're running. And then afterwards, you can catch them on either archive.org, which is on the Internet Archive, or they're sponsored and streamed by the Internet Society, the New York chapter. I don't know who the Internet Society is, but it seems fitting, you know, they're into streaming. So they basically have the tracks broken up then. So there's 3 major tracks that are split up by the auditorium name. They had all kinds of different talks about all kinds of different stuff. It was very interesting. The weird part of their website is that the talks actually go to the right a long ass ways. So they had these 3 kind of main speaking tracks, and they had a whole bunch of workshops and a whole bunch of other things going on in parallel with these tracks. The only things that are streamed online and recorded are the 3 main tracks. All the rest of stuff, there was like a pop-up kind of course where anybody could present something if they were around or had something to share that they were interested in. So at any rate, I gave a talk called Hacker Space to Hacker Home. The objective was to kind of detail the last 14 years of Sector67's existence, starting from me presenting a business plan idea at the university and kind of like how far could I get in 50 minutes. There's a limitation on how many years you can cram into 50 minutes, and so I did not cover all the way quite to the home part of it. But the idea is a lot of hacker spaces follow some things called design patterns. Design patterns are the idea of like, if you create an environment that has this rule or this guideline, you'll have a successful outcome. And so anyway, there's a bunch of design patterns online. And so I kind of gave the talk as though I was sharing a design pattern of what you could do from more of a business sense of like how to actually execute or run a hackerspace, which you don't hear very commonly from the people who run hackerspaces. So I thought it'd be interesting to share that perspective. At any rate, these streams are saved forever online. All the tracks that you can see at the right side, they're starting to compile these and detail them out. They'll eventually get broken up and posted on YouTube as individual videos. YouTube obviously has way more traction than some buried Internet Archive live stream. But these are all there. The speakers come from all over the place. I'm signed out. And I took some pictures while I was there that I thought you all would like. There was kind of everything under the sun. This person's a grade school teacher, and they shared how to use educational robots in their classroom. And they kind of gave a primer on all the different types of educational robots that they see and they use and they're interested in. There was the anarchist hackers from New York who had some zines and some other printed out media, just kind of interesting to have printed media, but at any rate. And then in the foreground here, there's a bunch of people learning how to solder. And so they have kind of these continuous soldering classes and camps going on. There's a lot of lawyers there, surprisingly. There's seemingly a huge overlap between lawyers and computer science people. And so they were talking a lot about kind of some changes with copyrights, AI stuff, things like that. I don't know if does anybody know who Jason Scott is? I had no idea who the hell this guy was. So this guy gets up and he gives a talk, and his title is A Preparation Kit for Increasing Irrelevance. And so he's like, who's here because you know who I am? And like 3/4 of the room raised their hand. Who's here because they saw the title and they thought this would be interesting? It's like me and like one other person are like, oh, we're here. It turns out Jason Scott is the founder of the Internet Archive. So he started this like textfiles.org and tried to grab on and glom on old text files that were online that he felt were going away. And that ultimately spurned into becoming the Internet Archive. So this guy like is the Internet Archive. They had a bunch of old computers there. This was a self-described tech bro who wanted to solve global warming in a direct way. So he's selling global cooling credits. So the idea is he's taking a balloon, filling it with helium, which don't analyze this too hard, filling a giant balloon with helium and then letting it go, and he's bringing up sulfur dioxide into the stratosphere. And if you bring sulfur dioxide into the stratosphere and pop it, you'll get a certain amount of cooling because the sulfur dioxide has a long residency time way up in the air. The other way to do this was he brought along a helium tank, balloons, and effectively chalk. And it was the same thing. If it gets delivered to the stratosphere and pops, the chalk drifts for a really long time, so it reflects sunlight. And he was there more or less as a marketing scheme, and then also as like a help me, I'm trying to figure out what to do. I heard about this thing called hydrogen and it's cheaper, and I'm thinking I should go that route, but I'm not sure. And then he's running a spot tracker to track the height the balloon gets to. and you're paying for the credits if his balloon gets high enough to have successfully deployed in the stratospheric level. And if it pops early because they overfilled the balloon, then they'll launch another offset for you. So he's proposing to offset rather than carbon, he's selling cooling credits. Cooling credits aren't recognized, so it's just like a random thing you can do. But effectively you can offset your global warming by paying this guy to run chalk up, or you can do it yourself. So after the talk, he went outside with his bottle and his balloons and had the offer of like, well, you can't legally let this balloon go, but if you accidentally trip and drop the balloon and it happens to fly up, then you happen to make an impact. About the only interesting takeaway to me from his talk was that apparently it's legal to do this. The only requirement is you have to tell the government that you're trying to change the weather patterns. So as long as you disclose that you're launching a balloon to change a weather pattern, it's totally okay. There's apparently like no regulation at all because nobody's really playing with this. They had the 2600 Hacker Quarterly van, which is an old Helco van. I don't know if anybody knows. 2600 was the Captain Crunch whistle noise that gave you free long distance calling. That was the 2600 hertz. And then 2600 magazine is the quarterly magazine that comes out that covers a lot of the talks and things that are in here. Their society had a cool streaming rig, so they're streaming all the talks, which becomes very relevant when no one shows up to stream the talk before your talk. At which point you become the audio technician and the video guy, trying to figure out how the hell is this thing supposed to work. Eventually somebody showed up like 10 minutes into what this guy's scheduled time was. But in the time when he got there, he was like, well, I'll just teach anybody who's been trying to figure this out how this thing works so that you can help next time. So that was interesting the way that it was structured. Oh, what else? This old guy teaches at, I think, at Stanford, and he has broken like all of the locks, like every single lock that exists. This guy makes himself a pain in the ass for all of the companies. The question I asked him was, do you get threatened to get sued? And he said, I get threatened to get sued all the time, but I'm a litigating lawyer, and so no one actually does it because I would just go to court and it's fine with me. So it was very interesting, like the potential to do things depending on what your background and your training is. So in this case, this guy is an immense amount of privilege to be a huge pain in the ass in really large lock companies because they can threaten to sue him, but they can't effectively do anything because he doesn't care.
Yep, isn't the lockpicking lawyer is a channel or something?
The lockpicking lawyer is a different person, but no, this is just another guy. So he does consulting and contracting and locks. What else? Corey Doctorow gave us a talk. That was like the main kind of talk on the second day. That was about it. So, any questions on? Oh, yeah.
With the balloon guy, did anyone like?
I knew I was gonna get a balloon guy.
Did anyone confront him that he's trying to solve the problem with pollution?
Yeah, actually, that was one of the questions was, don't you recognize that you're distributing latex balloon all over the place? And there's a lot of like.
Funny, right? Not to mention this.
Well, and yeah, the sulfur dioxide eventually falls out and it can make acid rain, but at low levels. So interestingly, at stratospheric levels, the distribution is such that it's like, humans, we produce shitloads of sulfur dioxide, and so the impact of him putting it really high actually doesn't really matter much compared to lower level stuff that we produce. There was an interesting other point that was made that I remember reading about on his thing, which was that relatively recently they forced all of the big heavy cargo tanker, like the cargo carriers, to move into low sulfur fuels. So they had to reduce the amount of sulfur that was in the fuel that these giant like bunker, they're just burning like barely liquid tar. And all these huge ships that move cargo all over the world. So they did the right thing, right? They banned sulfur. No more sulfur in the fuels. It raised the temperature of the world. Because the sulfur that they were burning in the fuel was pushing out, or reflecting the sun, just like the guy's talking about, and it was making the world cooler. So by doing the environmentally right thing and removing sulfur, which then removed acid rain from the giant cargo carriers, they made the earth warmer as a result. So it's a really weird thing. This stuff is not well studied. And that's one of this guy's arguments is like, all these climate scientists know that if you put sulfur dioxide in the stratosphere, it will cool down the earth, but no one has just done it to see what happens. Everybody's talked about doing it, but nobody's ever like really done it to see what would occur. So his argument is like, well, if we wait so long that no one's gonna actually attempt this to gather data on it, it's gonna be like a problem by then, and you'll have to kind of do it live anyways. So why don't we just do it live and see what happens?
I'm not saying I agree with that, it's just.
About all the helium in stratosphere,
Well, yeah, that's
That's-
stupid part
that's
is he's
perfect.
delivering, yeah.
non-recoverable.
No,
yeah,
exactly. Yeah, it doesn't make any
How-
sense.
Yeah.
You say he was sending chalk up there, is that like chalk dust like into a balloon or something?
Yeah, he was putting chalk dust in the balloon and then filling it up, and then when it burst, it would distribute. Cause it just pops and blows all over
Alright,
the
so it
place.
wasn't just like tying a piece of chalk. to it.
No, it was, yeah, very finely ground chalk, but yeah, same idea.
It's all, I think it's more like reflected everybody.
Yeah, anything, the sulfur dioxide itself acts like a reflective, even though to us it's not reflective, but to sunlight it is, but yeah, the chalk dust is directly reflective. That's-
I mean, practically, how many balloons per average human offset does it take? And then how do you study that when you can't measure where your balloons end up popping?
Yeah, how many animals
Like, how do
died?
you know that?
Looking on the balloons.
This is a perfect segue into you should watch his talk, cause I was there and I watched it and he answers these questions, but I don't recall it.
Yeah.
It is actually a relatively inconsequential quantity. However, his argument is if you wait long enough in your life before you start offsetting your cooling, it takes larger and larger and larger because it snowballs. So it's this greater gain. So all of the carbon that you emit that's then trapping heat, the heat gain is like a logarithmic gain. So the longer that you wait, the larger and larger and larger that your component of heating is. So really, when you're born, you know, this is the best gift to a newborn. It's like, here's your cooling credit for your life. Right here, you're gonna sense the sulfur dioxide up there, you're good to go. I'm doing a great pitch for this guy, by the way. I don't have his website, I can't tell you where to go buy it.
So how many people rushed up to give him money at the end of the presentation?
0 people rushed up to give him money. There were a lot of people who lined up to argue about the environmental aspects of it in a variety of ways, both the helium, the latex that's going all over the place in the ocean. The like, you're a dumbass, this isn't studied, why are you doing this? Yeah, he had the whole gamut, which was good.
Helium in the stratosphere will reach escape velocities, I mean, that's.
Yeah, no, I mean, yes, his fortunately, he's using party balloon helium, so it's like, you know, a portion of good helium, but it's still helium that you're literally giving away, so. Alright, any other non-party balloon related questions? Yeah, Bernard.
Do you remember what Dr. talk was about? Did you say he talked?
Doctor talked for like an hour and change, it was like an hour and a half, he was up, and he talked about the enshittification of the internet. I don't know if you've heard of enshittification.
Yeah.
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 I forget if he coined it or if it's been coined. Essentially, the idea is just like now AI is snowballing. It's just getting worse and worse and worse. But the whole idea is that there's this direct loss of community. So it's not individual people making websites anymore. It's companies who are incentivized on clicks. Google's burying relevant results. You can't even get to the Google results that it claims it has. It'll say it's got 50,000 results. But if you get to like page 10, it's like there's no more results. So his talk was on just that happening and kind of the implications to both society and individuals, as well as the global implication of what the internet is good for and not good for. So yeah,
Certification was the dictionary's word of the year last year.
okay. And I can't, does it say where I got coined or not? Like who said it first? Okay, yeah, I don't remember.
I think it's Dr.
I was gonna say, I think it was, I just didn't want to misquote him, so. Anyway, he gave an interesting talk. I was thinking he was gonna be rambling at the end of an hour and a half. He actually did a very nice job. It's of course a run up to his book, so he's gonna publish a book, I think, next year, that he's working on editing. But like I said, all these talks are on archive.org. If you search for Hope 2024, otherwise, I can send out an email with a link to it too, but they're all great. I mean, these are all really smart people, myself not included, but I was in the tiny auditorium, not the big auditorium, so don't mind me. But yeah, they had a lot of interesting people, and a lot of these people have history with Hope for, you know, a number of years prior, so it's been going on for a really long time. Getting people to think about the way that we use technology and communications and social media, things like that. So it's cool to be there, and a cool conference to see the people that were drawn to it.
What were you saying about not being able to see all of Google's search results? What is that?
So basically Google will claim they have like 50,000 results available. So like you'll search for something and it'll be like, oh, this is page 1 out of 50,000 pages, but you can't reach the pages. Like you can't keep going to
Yeah,
actually
you
show.
go down that one all the time.
So like you only get to page whatever and it just won't go any further.
The interface doesn't give you that stuff.
It won't present results anymore. So it'll claim that there's like X results, but then it won't go any further. you can try, I think, play with it, see it.
No, but I mean. The idea.
Well, they're claiming that it's already presented you the things that it thinks is relevant. It's like it's artificially curtailing your ability to further look down like the long tail of search results. I don't know why, I never put it into this.
Incentivize, you only look at the first 10 pages, because that's what it is.
Well, that's the ad content rate is a much better match early on. But yeah, there was,
It's all bots anyway.
well, that's the other, there's a lot to unpack on that, but the idea is, yeah, the allegation is made that essentially you can't go further. I obviously haven't dug into it to see, but it's an easy experiment, which is just continue to hit Max to run a script that does that and see how far down it'll let you go. But yeah, there was a lot of other really smart people talking a lot of really other smart topics, and so it was cool to see all the stuff.
Is that phenomenon, is that this certification?
So part of it, I don't remember if it was Doctor's talk or if it was one of the others that I went to, but it might be in his talk, him talking about that Google doesn't present results anymore. I guess that'll be my lead is go watch his talk and see if it's in there, report back. But I think that was in there. At any rate, I definitely heard it from one of the presenters there regarding that Google is curtailing the results. No other questions? The last thing I was just gonna share was Jim and I worked on AtwoodFest this past weekend. Thankfully that's now done. AtwoodFest is a neighborhood festival right down the street here. The very abbreviated story was it's been run for like 10 years by Wilmar Center, which is a community center down on the Isthmus, in partnership with Barrymore and the Neighborhood Association for our neighborhood Sassy. Wilmar had stepped away and is kind of starting to slowly, Gary, who runs the Wilmar Center, sort of stepping away and retiring from some of his obligations. This was one of the things that he cut. The neighborhood was going to not run the AtwoodFest this year unless someone wanted to run the vending and the kind of do the technical side of the electricity, things like that. And then all the rentals and all the coordination for all this stuff. So anyways, I stepped up and said that we would help with it. I told Jim to help me with that. And so Jim got stiffed helping to do all the vendor stuff. But kind of the back end of AtwoodFest is like getting all of this stuff in the right spots. We had 800 feet of snow fence to put up so people wouldn't cross Eastwood Drive and get run over by cars when they were drunk. There is. Yeah. That's those pizza delivery drivers, those guys.
No, that was definitely the drunk people.
There's a ton of trash, porta potties. That's a weird car. Right? So the idea then was, so Sadiq, I had offered to Sadiq, like, it'd be cool to do something with the arm. That snowballed into seeing if you can get the arm to play checkers. So we carried the arm with the truck and trailer down to AtwoodFest, and I really ribbed Sadiq because I had to buy a generator that put out 220, because the regular generator puts out 120 volts. That thing, of course, runs on 220. So I had to buy a generator that had 220 out, and I was like, Sadiq, I bought the generator. Now you got to do something. So that's
the offset credits.
yeah. I did not buy cooling credits to offset the generator emissions, but so that's the fun of that. Ended up borrowing a trailer from Tim over at the cargo bike shop, which was nice enough to lend us a nice ladder trailer so I could haul around all the trash. Thanks to Aaron for the skull and the rib cage there. You get a lot more attention and people get out of your way if there's the person who was in the way last time stuck on the back of the bike. And then Sadiq was drawing quite a crowd before he voluntarily unhooked the robot. Oh, it's not working, I can't make it move anymore. The first day was beautiful weather. The second day we were worried about rain, and so we had it over underneath the Barrymore awning. Jim Witter was supposed to present. He's claiming it's windy tonight. It is not windy tonight, Jim Witter. He's got a 12-foot diameter globe that he made. It's a giant inflatable. What did he end up doing? It's just like tarp, right?
Yeah, it's just painters are taped together. He got a bunch of gourds, so they taped them together.
And then he laid out the continents and then had a bunch of kids paint it. And had it. He was trying to inflate it for the parade, but this thing is like 12-foot diameter to go on the bike path. It was a very interesting creation. And then really AtwoodFest is great when it gets dark out because then it's cooler out. It's way hot during the day. And there are an assload of people who show up for the event.
This is one of the benefits of being an organizer is you can go back to the guys running the audio and be like, oh, hey, I'm gonna go up in your truck and take a picture. And they don't really care. So yeah, that was AtwoodFest in a nutshell. We successfully, I think we're the first people who successfully did recycling at a neighborhood festival. They always pretend to recycle, it all goes in the trash. The Sierra Club, Madison or Wisconsin 350, and then I was stomping around the dumpster pulling trash out. We managed to get one dumpster full of recyclables, and the city said they'll actually try to recycle it. So whether it actually gets recycled, who knows? I may have to buy some.
All of it, 20%.
Yeah, well, that's just the plastic that doesn't get recycled. And then always the fun of picking up all the street barriers and getting all the road closed and road unclosed and all sort of stuff. And this was Jim's contribution. He made a very beautiful map of where all the vendors were supposed to go, which if the vendors had told us the accurate length of their booths, or their more importantly their trailers, it would have worked great. They of course lied to us and told us that their trailers were shorter and smaller than they really were. And so we have to figure out a way to make that work better for next year. So apparently we tried the carrot method of like, this will work really nicely if everything works. And I think next year it's gonna be fines and a stick method to get people to tell us accurate information. So at any rate, AtwoodFest is the last weekend in July every year. So if you want to help next year, it's put on by the neighborhood association and then us as well as Barrymore. Does all the music stuff.
And that's just additional fees per square footage that we're off by.
Well, that's what that's basically what we're working on. Well, we're gonna make a fine rather than making a prepaid thing, so we'll figure it out. Anything anybody else wants to share? Otherwise, you're gonna run out and do intros. Joe, take it away. Who are you? What do you do?
Joe, I've been a member, something like that, actually, I've been traveling this summer, so I haven't really been working on much of anything, but I've been doing some just furniture and stuff like that.
What's your day job?
I teach at UW with the business school. Chris, been a member here for a while. And